Okay, so hopefully you were diligent and you actually did the homework. And you looked carefully at what happens to a vector if it's mirrored through 45 degrees and came to your own conclusions. Let me walk you through it. Here we have a vector x, and here we have our mirror, a line with respect to which we're going to mirror x. To mirror x, we drop a line perpendicular to this blue line, the mirror, and we go as far on the other side of the mirror as x is on this side of the mirror. The result then is the transformed vector x, which we denote by m of x. So the question becomes, can we scale a vector first and then mirror it and get the same result as if we first mirrored and then scaled? Let's have a look. Here's a scaled vector x. We drop a perpendicular line, and that's the mirrored image. If instead we first mirror and then we scale, lo and behold, we get the same result. Okay, let's see what happens if we add two vectors and then mirror. Here we have vector x, here we have vector y. We add them together, we get the diagonal of the parallelogram, and then we mirror that. Or we could take our vector x, take our vector y, mirror x, mirror y, and then add them together. And actually we get the same result. So here's the parallelogram at that right there. Here's the mirrored parallelogram. And lo and behold, if you add the vectors first and then mirror, you get the same result as if you first mirrored and then added. So let's review. A vector function L is a linear transformation if you can scale first and then transform, or transform first and then scale. And you can transform first and then sum, or sum first and then transform. From what we just went through, it appears that reflecting a vector in 2D with respect to a line, as illustrated, is an example of a linear transformation. Now, obviously, it could be that the specific examples I chose merely gave that impression. However, you can actually with geometry prove this as well.